Hi guys, welcome back to my channel. Hope you are doing well. Today I'm going to teach redox reactions. I've already started redox reactions and we have seen how to calculate the oxidation state of each element in the compound. So I want to do the various example and we can work out the oxidation state of each element by two methods. One is the formula method by using formula, and another method is just by drawing its structure. Drawing its structure is the 100% secure way to figure out the oxidation state of any element in the given compound. But for that, we have to either memorize or we should know the structure of each compound. Let's use both formula and the drawing. So let's do oxidation state of S in SO2, SO3, H2SO4, S8, and we have sulfur dioxide, sulfur trioxide, sulfuric acid, S8. Let's do H2SO3 and S8. Sulfur dioxide, S double bond O, double bond O. Among sulfur and oxygen, which one is highly electronegative? We know oxygen is highly electronegative, so -1, -1, +1, +1, because 2 minus, -1, -1, +1, +1. Oxidation state of sulfur, it's +4. SO3, double bond O, double bond O, double bond O. So -1, -1, -1, -1, -1, -1, +2, +2, +2. 6. Sulfuric acid, as double bond O, double bond O, OH, OH. -1, -1, -1, -1, oxygen -1, -1, -1, +1, +1, -1, -1, -1, +1, +1. So here +2, here +2, these two +2, these two +2, +1, +1, also 6. Let's do SO3, S double O hydrogen, O hydrogen, double bond O. -1, +1, -1, +1, +2. From that +1, from this side +2, -1, -1, -1, +1, -1. So from that side +1, +4, 1, 2, 3, 4, +4 oxidation state. Okay, S8, S8, sulfur here form a crown-like structure. So there will be no difference in the electronegativity of the sulfur. So S in S8 equals to 0 in its pure form. Here 0, 0, because there is no difference in electronegativity. 0, 0, 0, 0, 0, everywhere is 0. Can we use the formula to figure out the oxidation state of sulfur in all these compounds? Yes, we can use the formula. I want to try sulfur, this sulfurous acid. This is sulfuric. I want to try that one. Okay. Can I rub the board? Look at that one. Sulfurous acid. Now, I want to work out the oxidation state of sulfur in sulfurous acid. This is sulfuric, H2SO4 plus 6. Let's see. Hydrogen plus 1, we have 2 hydrogen. Sulfur, we don't know, X. Plus minus 2, oxygen is always minus 2, except when oxygen combined with fluorine or peroxides. Times by 3 equals to 0, because overall oxidation state is 0. So 2 plus X minus 6 equals to 0, X minus 4 equals to 0, X equals to 4. So we have some books, it is given as this is sulfuric acid but plus 6, this is also sulfuric acid but plus 4. Oxidation state of sulfur in this sulfuric acid is plus 4, so plus 4 sulfuric acid plus 6 sulfuric acid. Now we will do oxidation state of chlorine in different compounds of the chlorine or phosphorus. Let's do the phosphorus first. Oxidation state of phosphorus in its various compound. A, PH3, which is phosphine. B, phosphoric acid. C, H3PO3. D, H3PO2. And last one, EP4. Let's see. Phosphorus also showing variable oxidation state. Let's see. Phosphorus, hydrogen, hydrogen, hydrogen. So hydrogen is less electronegative, negative plus 1, plus 1, plus 1, minus 3. So minus 3 oxidation state. Now H3PO4, PO hydrogen, O hydrogen, O hydrogen, double bond. Phosphorus can form 5 bond, 1, 2, 3, 4, 5. Okay. Phosphorus is a less electronegative compared to oxygen. So minus 1, minus 1, minus 2, minus 1, plus 1, plus 1 from the phosphorus, minus 1 from the oxygen, minus 1, plus 1, minus 1 from the phosphorus, minus 1, minus 1, plus 1, 1, 2, 3. So plus 1 from here, plus 1, plus 1, plus 2. P equals to 5. 1, plus 1, plus 1, plus 1, plus 2. Okay. I will do from the formula, guys. H3PO3, PO hydrogen, double bond, hydrogen, OH, ONH, and H. Which one is highly electronegative among oxygen and phosphorus? Oxygen. So minus 2, 1, 2, so plus 2, minus 1, plus 1, minus 1, plus 1, plus 1, minus 1, minus 1, plus 1, minus 1, minus 1, plus 1. Here, hydrogen is less electronegative compared to phosphorus. So phosphorus is minus 1, plus 1. So total 2, 3, 4, minus 1. So plus 3. Look at that. 2, 1, 2, minus 1. So plus 3. Phosphorus also showing variable oxidation state. P block elements always show variable oxidation state. Now phosphorus in P H3PO2, P double bond O, hydrogen, high O and H. Minus 2, plus 2. Plus 1, minus 1. Plus 1, minus 1. Plus 1, minus 1. Minus 1, plus 1. Plus 2, minus 2. Plus 1. So plus 3, minus 2. Look, plus 2, minus 2, minus 1 cancel, plus 1. P equals to 1. So it's showing minus 3, plus 5, plus 3, plus 1. Variable oxidation state. And phosphorus is 0. Phosphorus like a tetrahedral molecule. Phosphorus, look at that. No electronegativity difference, 0, 0. So phosphorus equals to 0 here. Now, we will see some NO2. We will see the oxidation state of nitrogen, NO2, carbon, CO2, chlorine in carbon tetrachloride. You want to do with by using formula, any one of the example by using formula. Okay, let's do this one by using formula H3PO2 equals to 0, hydrogen plus 1 times by 3, phosphorus I don't know, so X plus minus 2 equals to 0, 3 plus X minus 2 equals to 0, X equals to 1. Oxidation state of nitrogen in NO2, NO3, HNO3, NO2, double bond O, double bond O. I know nitrogen cannot form 4 bond, but for time being, just think it form because it has a dative bond. Just ignore the point. And B nitrogen, double bond O. It can form dative, so let's do the NO3 because of the dative bond. I don't want to take that one, sorry, just because nitrogen can't make many bonds. So we will do this we will do this structure by using formula. So nitrogen minus 1 plus 2 minus 1 plus 2 minus 1. So N equals to plus 4. Okay. N hydrogen, a double bond O, HN 1, 2, 3. Plus 1, minus 1, minus 1, 1, 2, 3, 3 hydrogen. Minus 1, plus 1, minus 1, minus 1, minus 1, minus 1, plus 2. Okay, I don't think because of the dative bond. Let's use the chemical let's use the formula to figure out, not the chemical formula to figure out oxidation state of nitrogen in HNO3. X, hydrogen is plus 1, plus X minus 2 times 3 equals to 0. 1 plus X minus 6 equals to 0. X equals to plus 5. Here also equals to 0. Because of the dative, nitrogen and oxygen sometimes form a dative, 100% forming a dative bond. That's why I can't draw the structure. The structure will not help you to figure out the oxidation state of nitrogen, but we can use the formula. Nitrogen X plus minus 6 equals to 0, X equals to plus 6. Okay, carbon in CO2, C double bond O, C double bond O, minus 1 plus 2, minus 1 plus 2. So C, oxidation state of carbon in CO2 is plus 4. In carbon tetrachloride, C, Cl, 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 Cl. Now, chlorine minus 1, minus 1, minus 1, minus 1. So this is plus 4. Carbon equals to plus 4. Okay. Now we have some specific compounds which we cannot apply this formula to figure out the oxidation state of particular element. Let's see that specific examples. Now, sodium tetrathionate. First we will do hydrogen peroxide, H2O2. Let's see, H2O2, hydrogen peroxide. H2O2 plus 2 plus hydrogen and oxygen, suppose we don't know, 2x equals to 0. So 2 plus 2x equals to 0. 2x equals to minus 2. X equals to minus 2 over 2. So minus 1. Let's draw the structure of hydrogen peroxide. It's just like an open book shape. Plus 1, minus 1. So each oxygen has minus 1 oxidation state. Minus 1, plus 1. One more example. Sodium tetrathionate, Na2S4O6. We cannot. Let's check the oxidation state of sulfur by using formula. So Na plus 1 times by 2 plus 4x minus 12 equals to 0. 2 plus 4x minus 12 equals to 0. 4x minus 10 equals to 0. So x equals to 10 over 4 or 2 or 5 over 2, which is 2.5. So we can't work out by using this formula. Let's draw the structure and see what is the oxidation state of each sulfur in sodium tetrathionate. Look at that one. I will draw a structure and you can clearly see what is the oxidation state of each sulfur in that structure. So we have sulfur, double bond O, Na, sulfur, double bond O, O, Na, O, Na, O, Na, sodium tetrathionate. oxygen minus 1, sodium plus 1, minus 2, so plus 2 here, minus 2, each oxygen minus 2, so plus 2 here, minus 1 plus 1, okay. Here sulfur, sulfur 0, sulfur, sulfur 0, sulfur, sulfur 0. So minus 2, minus 2, this is plus 2, plus 2, minus 1, plus 1, minus 1, plus 1. So each sulfur has plus 5 oxidation state. This sulfur has plus 5, this sulfur has 0, this sulfur has 0, this sulfur has plus 5 oxidation state. This is actually the average oxidation state of all the sulfur, which is wrong. We can't use the formula to figure out the oxidation state of sulfur in sodium tetrathionate. One more example. Sodium tetrathionate. Let's do one more example. Okay. Find the oxidation state of chromium in CrO5 and bromine in Br3O8. Let's use the formula first. Chromium X plus minus 2 times by 5. Minus 2 times by 5 equals to 0. So X minus 10 equals to 0. X equals to 0. I don't think so. Look at that. Chromium has this type of structure. Chromium in CrO5, that's the structure. This is the structure, like a butterfly structure. Oh, now look at that. This is minus 1, minus 1. So this is plus 2. Plus 1, minus 1. Plus 1, minus 1, plus 1. Minus 1, plus 1. Minus 1, plus 1. 2, 2, 3, 4, 5, 6. So chromium oxidation state is plus 6. This oxygen minus 2, this oxygen minus 1, minus 1, minus 1, minus 1. So chromium is having plus 6 oxidation state. So when you use the formula, we can't get oxidation state of chromium is showing as plus 5, which is wrong. So sometime we have to just practice the drawing of the compound or just memorize the structure of the compound. I want to use the formula. So 3x minus 3x plus minus 2 times 8 equals to 0. 3x minus 16 equals to 0. X equals to minus x equals to 16 over 3, which is more, which is 3 5s are kind of more than 5. Let's draw the structure and try to figure out what is the oxidation state of bromine in Br3O8. Please copy down that one. Bromine in Br3O8. Got that. Bromine, 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 double bond O, 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 double bond O. So this is minus 2, this is minus 2, this is minus 2, minus 1 2, minus 2 minus 2. So here plus 6. Agree? Plus 1 plus 1 plus 1 plus 1 plus 1 plus 1. Bromine bromine 0. This bromine 0, this bromine 0, because there is no difference in electronegativity. Minus 2, so plus 2. Minus 2 plus 2. This bromine has oxidation state plus 4. Here minus 2, minus 2, minus 2. So my plus 2, plus 2, plus 2. So this bromine, what's the oxidation state? Plus 6. For this bromine, what's the oxidation state? Plus 4. For this bromine, what is the oxidation state? Plus 6, like that. So sometimes we can't use the formula. We have to use the structure of the compound. But mostly we can use the formula. The problem is that some molecule, they have a peroxy linkage. Then we can't figure out the oxidation state of each compound in a peroxide, in a superoxide, or this type of structure. So I want to wind up my video here. If you have any question, please write down in the comment box below. I will get back to you. Thanks for watching my video. Take care. Bye bye.